Hello and welcome to another video of Dr. Mahmoud Al-Odeh, and this is uh, Lean Six Sigma. In this video, I will be talking about using the Six Sigma methodology or the DMAIC to improve speed, quality, and cost. So in this video, I'll be talking about what is Six Sigma, what are these phases that Six Sigma use, and what the best tool to use. By the end of the video, I will be talking about a practical example, a simple example that will help you to understand what is Six Sigma. So let's go ahead and start with a Six Sigma. What is a Six Sigma? Six Sigma, it's a structured problem-solving technique that we use in business to improve quality. The letter, which is DMAIC, D-M-A-I-C, stands for define, measure, analyze, improve, and control. So this is the Six Sigma methodology. It is a process improvement technique, and it stands for define, measure, analyze, improve, and control. So whenever you hear Six Sigma, that means the DMAIC process. Going through these phases that we will be discussing in details in this video, and we will be talking about what the activities in each of these phases. These phases lead a team to logically define a problem. And this is what we need in a problem-solving team. We need the team to follow a logic process that will help them to identify the root cause of problem, and that will help them to implement a solution. The structure of the DMAIC encourage creative thinking within boundaries, such as keeping the basic process, product, or service. So that's the whole goal of the DMAIC, the Six Sigma. It's we need contribution from everyone. It's encourage creative thinking with not changing a lot with the process. Just one last piece of information about the Lean Six Sigma or the Six Sigma methodology. It is developed by 1980 by Motorola company. All right, now before we talk about these details and what's the Six Sigma, I want to share with you some of the levels of Six Sigma trainings that are available in the market. So you should be aware of this. You could understand what every training level means. So let's start with a black belt. Black belt, it's expert in Sigma, in the Six Sigma. It's highly skilled in the application of rigorous statistical tools. These rigorous statistical tools, advanced tools that will help the organization. So the black belt is familiar with these advanced statistical tools that will help company to improve process. And these black belt, usually they're one of their responsibility is to train green belts and other black belts as well. Once they gain knowledge and experience in the field, they will move on into the next level, which is master black belt. This is the highest level in the Six Sigma. If you become a master black belt, that means you're highly qualified, you're highly knowledgeable with the statistical tools, and also you have applied Six Sigma methodology, and you achieved a positive results. And that would be the top of the Six Sigma training. Moving into another category for the Six Sigma, the champion. The champion, it's not the certificate, it's not the level of education, but there should be a champion for the process. And this champion is in charge of the day-to-day operations. The champion responsible to provide all the resources that is needed for that project. So it is a project and we need resources, whether people, money, machines. The champion is responsible for that process. Green belt, that's before the black belt. Black belt is having an extensive knowledge in statistics. Green belt trained in the methodology and tools needed to work effectively in a project. Green belt work under the direction of a black belt, and these are basically familiar with the DMAIC process, the DMAIC phases. They might handle complex project on their own. They could be challenged and give them some complex project, but usually these complex project goes to the black belt, and the black belt will need some green belt people to work with him. But yeah, they're working under the direction of the black belt. And the last and the least level of the black belt of the Six Sigma certification is the yellow belt. The yellow belt trained in Six Sigma techniques, perhaps as part of company-wide training. These employees are not expected to actively engage in quality improvement activities. So the yellow belt, they're not expecting, they should be just familiar with the process. The green belt, they are expected to be part of the process improvement. I did put a link here for an organization, sixsigmastudy.com. I highly recommend this this organization, and they have a really excellent, high quality training, free training to become a yellow belt certified. So if you are interested in becoming a yellow belt certified, go to this link and register yourself. It's a free, and you will earn the certification. All right, let's go back to the Six Sigma. What is a Six Sigma? The Six Sigma, whenever we say Sigma, that means the average, the standard deviation, of the process. It's a statistical tool. It's a statistical tool that we use it in most of the math and statistic examples. So Six Sigma, when we say Six Sigma, that means we have a target of having 3.4 defects per million. 5 Sigma, if you reduce the quality from 6 Sigma to 5 Sigma, that will result in 230 defective parts per million. The good parts on the right side here on the yellow, that's the good part, 99.99966%. These are good parts. Only 3.4 per million parts are not good, are defective. On the 5 6 Sigma, 99.977% will result in excellent quality, accepted products or service. So defects per part, the Six Sigma aims to achieve the 3.4 defects per million. Going back to the 1 Sigma, as you see, versus the 1 Sigma, 690,000 defects per million. There's a big difference, which basically 30.85% as a good part. I want to take a look into this here. On the left side chart, what you see on the left chart, you will see a bell curve with 6 Sigma, 4 Sigma, and 2 Sigma. So the bell curve, as you see, the middle line, it's the target. This is the mean. And how far you are from the mean is the sigma. So the 0 is the target. +1 is we are away from the target by 1 standard deviation. +2, that means 2 standard deviation. 3 means 3 standard deviation. So what's the goal is? The goal is we have the upper specification limits and lower specification limits. These are the tolerances, basically. And we need to see what's the 68% of the data will fit under that, under the 1 +1 and -1 standard deviation. 95% of the data will fit between +2 standard deviation and -2 standard deviation. And 99% of the data should fit between +3 and -3 standard deviation. So what is the Six Sigma? Still not clear. I understand that some of you still confused about the Six Sigma. What we need with the Six Sigma, we need to narrow down the data. We need the data to be clustered around the mean. This is the goal. The goal of the Six Sigma is to remove the variation and bring the variation to be closer to the mean, which is this line here where you see the X. So the more the data is clustered around the mean, the less variation, which means higher quality. The flatter, see, the flatter the curve is, that means the more variation. All right, let's go over this important information, some definitions. The Six Sigma is a set of techniques and tools for process improvement. It was introduced by engineer Bill Smith while working at Motorola in 1980. It is a data-driven, so that's an important thing. The data technique to improve process and reduce defects. Six Sigma is a level of quality producing frequency of defects per million part, DPMO, defects per million parts or opportunities. That is a six standard deviation from the given mean. So that's the goal. The goal is we need to have to produce a data, a product, service that can fit within the six standard deviation from the given mean. All right, let's take a look into the more information about the difference between what's the 3 sigma, what is the 6 sigma. What we need to do, the 6 sigma, basically, we need the data again to be close to the mean. The closer clustered the data is, the better. The narrower the curve is, the better. And in this case, we could fit 6 standard deviation away from the mean, and that would be the perfect situation. So on the B4, here's a study for bullets produced. For the B4, we were able to see that there are 3 standard deviation, 3 standard deviation or 3 sigma. And these are the specifications, the customer specifications. As you see the red area here, these are defects. You're not going to take them. The customer will not going to take these. These are defects. There is out of specification, so they're not used. So that's a 3 sigma. Now, after working on the process, we were able to remove the variation from the process. And then the polar dimensions. Now, as you see, after creating the bell curve, that will result into fitting 6 sigma, 6 standard deviation around the mean, right or left. And that would mean we narrow down the standard deviation. So the standard deviation here was, for example, 50. In here it was 10. So we reduced the standard deviation. How far the variables from the mean. So now in this case, we were able to produce a process with a 6 sigma capability. And now there's no defects. There is no defects. All right, what is a 6 sigma? A 6 sigma, it's a DMAIC process: define, measure, analyze, improve, and control. We're going to go over these phases to explain what is the 6 sigma. This process will result in having 3.4 defects per million parts. Starting with the first one, the define. The define phase. The first thing what you need to do as a 6 sigma team, you need to define The problem. You need to define the problem. There's so many questions that you have. So you have to find answers for these questions. You probably need to negotiate your payment for that project or adjust the scope for that project. You need to negotiate resources. What resources do you need? Before starting, you need to define these upfront in order to do this. The time frame. How many members on your team going to be? Okay, assuming that you're done with the negotiation part, you're happy with the team, you're happy with the pay, now let's go and dig deep into this phase. First thing, you need to validate the problem. You don't want to just listen from the employees or from somebody saying that we have an issue with a specific machine or the defect's high. Okay, is that true? Based on data that you collected or based on the historical data, did you see that? Did you see that issue? So what we need to do first, validate problem. Put the goal. And how we do that? By reviewing existing data or sources of information to confirm the problem that you were given. So whether you review the existing data, or you probably do the time study by yourself, or you monitor the process yourself to collect the data and verify it, or somebody is trusted source that could confirm the problem. Is it exist? Does this problem exist or not? Is it important to customers? Where did they get that data from? Is it from a survey? Could be. Is it important to the business? Is it coming from the voice of the business? Also, what we could do, maybe we should ask, can Six Sigma methodology solve the problem? Can the DMAIC process will solve the problem? This is what some of the questions that we should ask. Validate the financial benefits. If there is some financial benefits, you should validate that. Again, you need to use existing data to calculate the current cost and estimate the financial impact if you achieve the projected goal. Okay, we have 20% of customer complaints. If we reduce that to 10%, what's the impact? Is that going to be more profit? Well, if you can do that, that would be great. Number 4, create, validate process map. So the first thing that you want to do in order to understand the process, create a flow chart, the process map. The process map will document all the process in this, all the steps in this process. And then create a communication plan. You have to have a communication plan to identify who's the participants, the stakeholders, and develop a plan to keep them informed. Complete project plans. That's number 6. You create the Gantt chart, stakeholder analysis, resistance analysis, risk analysis, action logs, responsibility assignments. So in the plan, in the first phase, you do a lot of planning. The most important thing is to accept the project, identify the resources that you need. You could negotiate the membership of team, you could negotiate the resources and these other things that you need for the project. Also, you need to verify the problem, whether using a historical data, past data, or you collect the data by yourself. And one of the things that you want to do is create the process map. So in the define phase, you need to create you need some data, you need to create a process map. And also as a team, you want to make sure that all your members are on the same page and you have a clear communication plan. And when is the due date? When you have to start? The Gantt chart would be a great way to include all these, the Gantt chart, the stakeholder analysis, the risk analysis. If you could have that clear from the beginning, that would be great. For the tools that we need to use in this phase, in order to validate this problem, we need to use the check sheet, Pareto diagram. We could use scatter diagram, histogram, cause and effect if diagram, process map, surveys for customers, maybe personal visit and interviews, brainstorming, and historical data. So there's so many ways to define the problem. You need to follow the 7 quality tools that we discussed in previous videos and previous chapters in order to define the problem, clearly define the problem. What's the Six Sigma is different than the DMAIC cycle? This is taking the project management methodology. It's not just only identifying the problem, not just only define the problem, but also define the resources that you need. Define the membership of the team that you will have. Financial aspect of it. Creating Gantt chart to know exactly what's the timeline for you to finish this project. Create a goal for you. So this is more comprehensive than the DMAIC. The DMAIC is, they provide some really good structure plan, the do, study, act, the do, the PDSA plan, do, study, and act. These are very structured cycle for process improvement, but the Six Sigma is more comprehensive because it's taken the DMAIC cycle and the project management methodology, they mix them together and they give you a more comprehensive tool to implement, which will result into a better achievement, better improvement, more efficiency for your process because you covered all the details. So again, in the define phase, you need to define the problem. What is the problem? In addition to that, you have to define the scope of your project, timeline, resources, risk analysis, and other important aspect related to the project. The next phase is the measure. In the measure phase, what you want to do is you need to validate the value stream map. You need to create a value stream map. Now we need to measure. Now we identify the problem. We know that there is a long wait time. So now what you need to do, you need to dig deep and look into the value stream map. If you remember the value stream map, it is a more detailed process map, a process map that has the time for each phase. So you use the process map, the basic one, but what you do, you define the time and other process data related to the map. So you start doing the time studies to add the time to the process map. Identify the outputs, the input, and process variables relevant to your project. Create a data collection plan. What is your plan to measure, to do the measurement? Do you have a plan? If you're doing a time study, for example, are you going to do just only one time study, or are you going to do 3 or 5 or 4 or 5 and then take the average? This is what I do. I take 3 time studies for one process and take the average just to be more accurate. So you have to have a clear plan for collecting the data and what measurement system that you're going to use. Make sure that it's accurate, consistent, and reliable. Collect the data to establish the baseline. So if we know there's a problem, but we don't have any baseline, so this is a good phase to establish the baseline. Why it's important? Because once you do the improvement, you have to compare the before and after. The before and after is really important, and you have to have some baseline information in order to compare it with the after that. You could do the calculation for lead time and do the little low, which is talking about the work in progress. And then We could do the process capability evaluation. What's the process is capable? What level of Sigma right now? And if you could do a quick improvement, why not? You could do it right away. Maybe just, a simple adjustment of a machine, it would help and solve the whole problem. Then review the phase and look into what you have achieved so far. Some of the tools that you use in this phase: value stream map, time studies. You could do control charts just to establish the baseline, run chart. You could do historical data. You could do yield reports to define the baseline of performance. The next phase is the analyze. Analyze phase. In the analyze phase, you need to identify, you look into the value stream map. You have a value stream map, and you have putting all the information there, all the times, from step by step, from bringing the raw material to send the product or service to the customer. What you need to do when you do the analysis, you need to look into the value added, these activities that add value to the customer, and these activities that does not add value to the customer, and that where you want to remove it. You want to remove it from the process. Process cycle efficiency. Look into the tacket time, for example. How efficient is your process? If I produce 100 parts, how many of these parts are defective? This is what could be the efficiency of your process. Analyze the process flow, identify bottlenecks if there is some bottlenecks and constraints, fallout and rework points, and assess their impact on the whole process and the throughput of the process. Analyze the data that we collected in the previous phase. This is what is mainly taking the data from the measurement phase, from the measure phase, and look into that, interpretate the data. And based on this data, we need to do some actions that would be in the next phase, in the improve phase. Once you looked into the data, there may be some more issues that you weren't aware of. That once you looked into the information, you said, oh, okay, well, I see that. Once I looked into the process, the control charts, I see where's the problem. The night shift is the problem. So that would take you into a more focused point of view. You look into a more detailed insight of the problem. And therefore, you need to probably explain potential cause of the observed effects. Maybe you need to narrow down the search for root causes and significant causes and effect relationships. Maybe you need to further investigate by collecting additional data. You were not able to verify the root cause of the problem. So you need to probably bring more data and more information. Use a scatter diagram maybe to help you to find out the relationship between different variables. And then the last step, what you do, you review the phase and see what's the reflection of this phase. Some of the tools that you would do is cause and effect diagram, cycle efficiency. Maybe we could use the lead time, the wait time, the effective parts. Also, you could do scatter diagram, as many tools as you want, as long as you are able to analyze. So it depends on the situation. If there's a further investigation, maybe that will take you to the previous step and do the tools again one more time to reflect, to find the actual root. This is maybe where you need to narrow down the search for the root causes. And you have to collect a further data and more data to investigate the problem. In the improve phase, now we clearly define the problem. We clearly measure some data. We analyze it, and we found out what's the cause root of the problem. And then now what we need to do, it's time to do the improvement. And what you need to do the improvement, you have to do some design of experiments. try different experiments, different variables, and see if that's going to solve the problem. Develop potential solutions. In this phase, we develop potential solutions, use confirmed cause and effect analysis from the analysis phase to identify a wide range of potential solutions, evaluate and select the best solution, flesh out solution ideas, develop a criteria to evaluate the alternatives, document the results. In the improve phase, what we need to do also, we need to do another value stream map. So we did the value stream map for the before, we implemented the potential solutions, we do the future map and we compare it. Did we improve that? Did we reduce the lead time? Does this the improvement that we implemented does remove all the defects? We have more happy customers. So you need to develop to be, or the future value stream map, revise the existing value stream map to reflect on what the process will look like after changes are made, include estimate of time, savings, improve quality, and so on. Develop and implement pilot solution. Confirm attainment of project goals. Develop and execute full-scale implementation plan. And the last phase is to review the phase. That would be the last step. Once you finish this phase, just review it and see what's potential solution, what tools I should use. Can I develop the full scale now, or should I do small scale? So you could do that. This is some of the things that you want to consider if before you implement the full solution, you probably want to try it on a small scale before you do the full implementation. Some of the tools is design of experiment, which is basically playing with the factors and see what's the outcome. In value stream map, what we could do also is the time studies. Of course, we need to do some time studies to do the value stream map. And the last phase of the Six Sigma DMAIC process would be the control phase. In the control phase, you develop supporting methods and documentation to sustain the full implementation. Now, there's so many issues now. When you do the implementation, you don't have a documentation to help the team, to help the department to maintain these improvements. So in this phase, you need to develop some documentation. When you launch the implementation, you probably wanted to train these people. You need to train these people and make sure to monitor them. You know, it's hard to switch from the bad habit to a new habit, from the old process to the new process. So in this phase, what you need to do is to monitor the implementation through observation, interaction, and collection of data, and prevent people from doing the old ways of doing things. You probably want to do process control a plan, such as process control charts. And then once you're happy, you could hand off the control to the owner of the process. You may outsider of the department. You came to the department to help them, and now it's your time to go to another project. So you have to hand off the whole project, the control to the process owner. Audit the result. What we need to do, we need to confirm that the improvement has been effective. And the last thing you want to do is finalize a project through the review session. Celebrate. You need to celebrate with your team. You've done a great job with your team. We've achieved a lot of improvements, and now we need to celebrate with the team. Number 8, validate performance and financial results several months after the project completions. Just to make sure that everything's still in place, you probably want to do another audit several months after the project completed, just to ensure that things go on the same and nothing wrong has been happening in the lately. Some of the tools that we could do: a control chart, run chart, check sheet, and any tools that basically we did use in the define, just to keep an eye on the process and make sure that the process is going well. The one thing that I want to mention, there could be different ways for implementing the DMAIC process, and one of them is very long, and the other one is accelerated, and what we call the Kaizen DMAIC. The Kaizen DMAIC, it's basically accelerating the DMAIC process. Instead of spending 6 months on implementing the Six Sigma project, we could do it in 1 week. And this is basically a sample of a schedule that you could use in the Kaizen DMAIC, which is basically most of the work going to go on the black belt and the sponsor of the project. They're going to do a lot of the work behind the scenes before involving the team, all the team. And this is one way, an effective way actually of doing it. But there's so much work on the black belt and the sponsor, the champion of the project itself. But this is, as you see, Monday, Tuesday, Wednesday, Thursday, Friday schedule, or they could implement that, and even they do the follow-up after that. This is another way for the way. But the another way for the other way for doing it, it's basically the long one, the long one, which is will take longer. And let's read about it. The project team approach, black belt deployed full time to project. So there is a full time for project team members work on the project as a part time, and these basically they need a full involvement by all team members in all phases of the MAC. During duration could be from 1 to 4 months depending on the scope. The other way, which is the Kaizen approach, it is a rapid, it's a 1 week and intense progress through the DMAIC, except full-scale implementation. Preparation work on define and sometimes on the measure done by a subgroup such as the black belt, the team leader. The rest of the work done by the full group during several days or a week, when they work only on the project. They are full-time on the project. So they're the other technique is part-time. These team members are part-time, but this one is a full-time. They have to participate, and these participants are pulled off their regular job. They said, okay, don't do this anymore. What I want you to do is focus on this project for now. You're full-time working on this project, on the DMAIC Kaizen project. The last thing that I want to share with you here, just a quick example, a simplified example that I used to hopefully help you better understand the DMAIC and the Six Sigma. So what I have here, there's a scenario for a quality manager in laptops. In this quality manager, notice that there is a high percentage of customer complaints. And what he did, and that was for the month of February. And what he did, basically, he formed a team to investigate and solve the problem. So the team decided to use the Six Sigma methodology to solve the problem. They followed the 5 phases, starting with the define. In order to do the define, the team count the number of complaints using a check sheet, and then use the Pareto chart to identify the most significant problem. Of course, this is only for problem solving. From a project management methodology, they have to identify the scope, the resources, what else? resources and timeline that they need. In the measure phase, the team tracked the damaged products, and it's found it's consisting of 23% of total shipped products. So this, they found, after they measure that, they found that these are damaged products due to shipping. They are consisting of 23%. These damaged products due to shipping consist of 23% of the total shipped products. They put the goal to be 10%, to reduce that to 10%. In the analyze phase, the team used the cause and effect diagram to find the root cause of the problem. And it is found that the packaging material is not strong enough to protect the shipped products. They used 5 whys tool, asking why 5 times to investigate the problem in more detail. It is found that the technical specification for their packaging process are outdated, as they have changed the packaging material last month. In the improve phase, the team designed few experiments to identify the specification and select the best specification for their packages. They used control charts to monitor the behavior of the process and to ensure that they select the best specification. Then they updated and revised the specification, which hopefully will result into stronger packaging or package for their products. In the last phase 5 control, the team monitor the customer satisfaction. They continue surveying the customer, and they use the check sheet to monitor the complaints of the customers. Now, the packaging process is kept within the optimum parameters and resulting in solving the problem. It is found that the number of complaints of the products due to shipping has not exceeded the 2%. So again, this is a quick simplified example of how you apply the DMAIC Six Sigma into the process improvement. I hope this is helpful. And that's the end of my video. I hope you guys like it. Please let me know if you have any question.